Hello everyone, this lecture video is all about triacylglycerol storage and mobilization under the lipid metabolism. So most cells in the body have limited capability for storage of triacylglycerols. However, this activity is the major function of specialized cells called adipocytes. So this adipocyte, this is the structure. This you have here the mitochondrion, the cytoplasm, and we also have here the cytosol in the cytoplasm. This cytosol contains the enzymes and hormones that is needed in the process of the mobilization of triacylglycerol. So, the difference of adipocytes to other cells is that it has a fat reservoir. This one is a large central lobule of triacylglycerols, which is what we know as the fat reservoir for the triacylglycerols. And then, of course, the cell membrane here. So, this adipocyte is located in the under of the skin, under the subcutaneous part of our skin. So this is your skin, this is the tissue here, and this is the fat located in the subcutaneous part. And if you will look that in the electron microscope, you will have here the fat cells. So next, the adipocyte is a triacylglycerol storing cell. This is the specialized function of this cell. Then adipose tissue, it is a tissue that contains large number of adipocyte cells. Then the location of adipose tissue, it is located beneath the skin or the subcutaneous part, as I have illustrated before. And then in the abdominal region, which is especially in our tummy and our stomach. And then the areas around vital organs. For example, in the areas in the heart, in the liver. So that is where the adipose tissue is located. But too much accumulation of fats in that area, of course, will lead to heart disease. Okay, because the blood cannot flow thoroughly because it is being interlocked or being blocked with fats. So, aside from its function as storage of location for energy, adipose tissue also serves as insulator against excessive heat loss to the environment. So it keeps us warm. And it also provides organs with protection against physical shock. So when we say physical shock, this is, for example, someone punch your stomach. So your stomach is a vital organ. So if you have adipose tissue, it lessens the impact and the damage that will induce on that physical shock. And also, when you fall on the ground, you have a liver and your kidney, right? So that is insulated by adipose tissue. So it prevents the physical shock or the damage that will induce by the physical shock. Okay, it prevents the damage on the liver due to that activities. And then we also have here the triacylglycerol mobilization. We can define this as overall process of topping body's triacylglycerol energy reserves for energy. And we have discussed that the adipose tissue as one of the triacylglycerol storage, right? So we will discuss now that mobilization. When we say mobilization, how is triacylglycerol being utilized into energy in the adipose tissue and adipose cell? So before we proceed on this definition, that is the conclusive definition, let us proceed here. I have here a diagram. Okay, so as I have mentioned, cell membrane, we have cytoplasm, and we have the cytosol. The cytosol here is where the enzymes and hormones are located for the mobilization of triacylglycerol. So, the use of triacylglycerol stored in adipose tissue for energy production is triggered by several hormones. First is the high level of epinephrine and the low level of insulin level in blood. So when that conditions had been met, the epinephrine will attach itself to this receptor site. This receptor site is what we call the beta-anergic receptor, and the epinephrine will connect here. This beta receptor site is located on the cell membrane of the adipose tissue. When that happens, it will trigger the adenyl cyclase, and it will stimulate the production of cyclic adenosine monophosphate and ATP inside. So this ATP here and the cyclic adenosine monophosphate will trigger or will stimulate the enzymatic reaction, and it will activate the inactive form of highly sensitive lipase. So when this interaction will happen through phosphorylation, to say addition of phosphate here in the highly sensitive lipase, which is you will have now the active form, which is the highly sensitive lipase phosphate, and this will cleave the triacylglycerol into fatty acids and glycerol. When we say cleave, again, you encounter the word cleave. It means division or breakage or splitting. So this is your triacylglycerol, and the highly sensitive lipase phosphate will cleave this It will mean to say it will divide this into 3 free fatty acids and a glycerol. Okay, so when this happens, when the cleavage occurred, there will be a release in the bloodstream of fatty acids and glycerol. So this is the bloodstream, and if this triacylglycerol had been cleaved, it will release that in the bloodstream. So that is how the hormonal interaction and enzymatic reaction inside the adipose tissue will tap the energy source of triacylglycerol. Okay, and then what else? And then I have here the stored energy reserves of various types for an average person which has 70 kilogram. So this is the normal type of energy reserve. You have triacylglycerol, protein, glycogen, and blood glucose. The amount of energy stored in terms of kilocalories, you have here 135,000, 24,720, and 80. And then the percent of total stored energy, you have here 84.3, 15%, 0.45, and 0.05. That is why also the triacylglycerol reserves would enable the average person to survive starvation for about 30 days given sufficient water, and the glycogen reserves stored glucose would be depleted within 1 day. So that is all for triacylglycerol storage and mobilization.